Welcome. This series of lectures is an introduction to building energy simulation. We'll go over a brief background of energy simulation and how it is used, learn how to benchmark your building to other buildings with known utility data, learn about some key model parameters and their typical values, introduce sensitivity analysis to see which parameters are most important in your model, and lastly talk about model accuracy and calibration. So why do we use whole building energy simulation? Well, there are two general applications. The first is building design. Say we are designing a building and we want to know whether we should increase the amount of windows on the south-facing wall. More windows will mean greater heat loss during winter and greater solar heat gain during the summer, which will cause the energy use to increase. But they will also increase the solar heat gain during the winter and may bring in more natural light to the building, reducing the need for installed lighting. We can use energy simulation to determine how many windows we want, particular to the building's location, and what that will mean for the overall energy use. We can use the simulation to calculate the thermal loads for specific zones, and therefore the sizing for the HVAC systems in those zones, and determine how much it will cost to heat and cool the building over the course of a year. We may also use models of thermal comfort for occupancy to determine whether some zones will be more uncomfortable during certain times of year or not. The second major application is in building energy retrofit, where we have an existing building and we want to know what changes we should make to reduce our operating expenses. Should we replace the lights, or should we install a more efficient cooling system, for example? So building energy simulation started back in the 1960s and expanded greatly in the 70s in response to the oil embargo, as did the rest of the energy efficiency industry. ASHRAE, the American Society of Heating, Refrigeration, and Air Conditioning Engineers, led a lot of this work, with two main programs being the DOE2, which was developed by the Department of Energy, and BLAST, which was developed by the Department of Defense. DOE2 and BLAST merged in the 1990s in the formation of EnergyPlus, and we'll be using that for our course. And DOE2 is still available as a GUI with EQuest, which is still pretty popular. And this is a graph of the market share currently of energy simulation. This is for LEED. This was LEED version 2 and 3, so that's sort of between 5 and 10 years ago. And you can see that EQuest and EnergyPlus, which are interfaces for DOE2, are pretty widely used. HAP and Trace are two load calculation programs for two major equipment manufacturers. Trace is for train, and HAP is for carrier, and they make a lot of chillers and other sort of equipment. So people like to use it because a lot of that equipment is pre-built into the software, so it makes the selection pretty easy. EnergyPlus is not so common here, but there's been recently a big rapid uptake in that thanks to the development of OpenStudio, which provides an object model interface for EnergyPlus and has a lot of built-in capabilities for changing things in the building and doing parametric modeling. I want to give one caution about energy simulation, especially since we brought up LEED. This is a graph of LEED buildings and their measured energy performance versus what was predicted by the energy simulation. There isn't very good agreement here. And for some cases, these buildings were still using much more than energy code and were way off the simulation value. There are two general explanations for this. The first is that the model is based on design drawings and sort of assumes perfect equipment operation and assumes a typical weather year, which are things that don't exist in reality. The second is that the modelers may not have done a great job of picking their parameters carefully. Particularly load schedules and occupancy are really difficult to determine beforehand. So just keep these in mind, that while these models are getting a lot more technically sophisticated and more accurate when they're in controlled settings, it's very important to make sure that you choose your parameters carefully, otherwise you'll get junk results. So EnergyPlus uses what's called an integrated simultaneous solver, and that's sort of a key difference between it and a lot of other simulation programs that are out there. And well, what do we mean by that? Well, in a lot of other simulation programs, you'll have a certain load that goes into a certain zone that will send information to the HVAC system of what it needs, which will send information to a specific piece of equipment, say a boiler or a chiller, saying, okay, you need to supply this much heating or cooling. and it goes one way. So if the chiller or the boiler isn't able to meet that, then the model sort of assumes it did anyways. EnergyPlus is simultaneous, where if it's not able to meet that, or there's some other reason that piece of equipment didn't actually provide the full load, that'll propagate back to the zone, and the air temperature in the zone is allowed to vary. So it doesn't always assume that the zones the loads in the zones are perfectly met. It allows those to vary, and that's matched with the plant. Some other nice features of EnergyPlus it uses in anisotropic sky model. There's a lot of other simulation softwares that do that, but that basically means it allows for direct radiation and diffuse radiation. So those are treated differently depending on where the sun is in the sky and how that interacts with windows in particular. EnergyPlus has got a lot of nice features for fenestration and blinds and shades and dimmers and such. So it's also integrated with the tool called Radiance in Studio, which is really great because you can get very accurate models of daylighting and the loads that you experience from solar loads through the windows. EnergyPlus focuses on the simulation code, and it was built initially as sort of a simulation solver. It was not meant to be a graphical user interface, and so that's why OpenStudio was sort of developed for that. And there's a few other ones out there, interfaces for EnergyPlus. Design Builder is a common one, and Symergy is another pretty common one. So keep a lookout for those if you're ever doing energy simulation in the future, and you come across those, you'll know that that's EnergyPlus in the background. The other nice thing about EnergyPlus is it's sort of modular code, and that was recently converted from Fortran to C++, so it's more approachable now.